Thank you for joining us this morning for this webinar on our bootloader recovery tool. The presentation itself is roughly about 14 minutes thereabouts, and if you have any questions you can pop them into the panel and we'll get to them at the end.
Welcome to today's tutorial. Let's get started. Let's have a look at our agenda for today. Today we're looking at the updated OCS bootloader recovery tools. First, we'll do a quick review on what is OCS firmware. Then we'll talk about when we would use these bootloader recovery tools, and then we'll go through that recovery procedure. Then we'll have a demonstration, and as always we'll finish with a Q&A session. So first we'll look at OCS firmware. OCS firmware is the code that runs on the OCS hardware, and it's the part of the code that is created by Horner's engineers. It provides the OCS product with its functionality and all of its features. The firmware is what actually executes the application program that the customer application engineer loads onto the OCS. There are multiple elements that make up the OCS firmware. First of all, there is the operating system. All OCS units use an operating system, and that varies depending on which OCS series you're using. For example, a unit from the Micro OCS family will be using a different operating system than a unit from the XL series family. What we call the firmware is actually just one of the three portions of code. Again, that's the code that's created by the Horner engineers. In addition to the operating system and the firmware, there is also either FPGA or CPLD code. That is code that runs in a high-speed coprocessor chip that handles all the high-speed inputs and all the high-speed outputs. That means all those signals can be handled outside of the main processor and they're not dependent on the main scan rate of the processor for their execution. So now we'll look at firmware updates. Depending on the OCS product you have, you'll be using a slightly different method for updating its firmware. If you're using one of our micro OCS products or the XLE or XLT, then you'll likely be using a USB cable connected to your computer and then using Cscape to update the firmware in that controller. If you're using an XL series product, an XL Plus or an X5, then you'll be using a file set downloaded from the web that is loaded onto the OCS from either micro SD or USB. Then, if you're using an RCC, you have to use a bootable micro SD in order to update the firmware on that unit. Remember, an RCC is an OCS that doesn't have a screen or a user interface that can walk the user through the firmware update process. So therefore, you need to use a bootable micro SD for updating the firmware on one of those RCC units. So what happens if a firmware update goes wrong? It is possible for that to happen, resulting in the OCS failing to boot. That could happen for a number of reasons. For example, let's say you had a power cycle at the wrong time. Let's say you have an XL series OCS that will no longer boot. In this case, using a bootable micro SD is an effective recovery method. We have a utility for creating bootable micro SDs available on the firmware page of the Horner website that we will look at shortly. So in summary, when am I going to use a bootable micro SD? So you only need to use it when a firmware update goes bad on an XL series model and you need to recover, when a firmware update goes bad on an X5 and you need to recover, or if you're doing a normal firmware update on an RCC because it doesn't feature a built-in screen or user interface, and in that case you're going to need to create a bootable micro SD. Next, let's walk through the XL series recovery procedure and then we'll go into a demonstration. The first step is you're going to need a micro SD card, and it's easiest if you get a micro SD card that is 32 gigabytes or smaller, which you should be able to find fairly easily. That's because they come pre-configured with FAT32 format. The larger ones come with a file format called exFAT, but we need to use FAT32. If you do have a larger card, you'll have to format it in FAT32 using a special utility on your computer before you can start the process of getting into this recovery procedure. Once you've acquired your card, you need to download the OCS Bootload Creator, and you can download that from the Horner website under support in the firmware section, or acquire it from one of your tech support application engineers. Once you've done that, you're going to install it on your Windows PC. It's an executable file and it works on Windows 7, Windows 10 and Windows 11. And once you've installed that, you insert your micro SD card in your PC and it's going to mount as a drive. And then you run the OCS Bootload Creator utility that you just installed. Now, in the process of running that, you'll need to select the controller model that you're using. You'll also need to select either 2-channel mode or 4-channel mode for high-speed counting. If you're not sure which one you need to select, then by default you can just select the 2-channel mode. Then the final thing you have to select is the micro SD drive letter for the micro SD card you've just installed. Now, once you run that utility, it will create a bootable drive for you. And then, when that's finished running, you can take that bootable drive out of your PC and install it on your OCS. Then, one of the following two things have to happen next. If you have an OCS with a dip switch for controlling bootable drives, then you're going to need to flip that dip switch and then apply power with the bootable micro SD card installed. On the other hand, if you have an OCS model that has a push button for booting from micro SD, then you need to hold in that push button while you apply power to the unit and then release it. Next, the OCS is going to boot, and remember before it wasn't booting. Then it's going to prompt you to install the bootloader in the local flash memory of the OCS, and then once that process completes, if it was a dip switch that we used to boot from microSD, we'll flip it back to its default position and then we'll complete a power cycle. And then once we do that, we should see a normal boot with some expected errors because we don't have a program installed and because we had an abnormal power down causing a battery type message, but it's not a real battery failure. At that point, we're fully recovered. So how do I know if the OCS I'm using has a dip switch for prompting the unit to boot from microSD, or if it has a push button? So let's look at that now. For the X5, the XL4 and the XL7, as you can see in these images, they all have dip switches. The X5 and the XL4 only have one dip switch and it's operator number 3 of that one dip switch that is used to boot from microSD. On the XL7 there is a dip switch on the side and a dip switch on the back. The dip switch on the back is SW1 and again it's operator number 3 that prompts the unit to boot from microSD. If you have an RCC, an EXL6, any EXLW or any EXL10, those units have push buttons that are recessed located near the mini USB port that's used for programming. In this image you can see what it looks like on the EXLW. On the rest of them it looks the same with the exception of the RCC. On that one it looks different, but the button is clearly labelled on the front of the unit. Now let's begin our demonstration where we'll look at that recovery procedure with an XL4. I'm going to simulate a firmware update that's gone wrong. So I have my XL4 controller running here and I want to do a firmware update. I've downloaded the XL4 file set for the firmware version that I want to download and I've put it on a micro SD card and installed that micro SD card in the XL4. So now I press and hold the system button, then the boot installer screen comes up. I'll press install bootloader and it says are you sure? I'll hit yes and it starts the process of doing the firmware update. Now let's say I had an unexpected power cycle. For example, I had a loose wire and now I'm in a situation where I'm no longer able to boot. So I'll try to power up the unit again, but as you can see with this XL4 we're getting nothing but a blank screen. I'll press and hold the system key to see if that helps me in any way, but it's doing nothing. So I have a situation where I have an XL4 which won't boot, and I need to recover from that. So now I'll go to my PC. Here we've installed our bootloader utility, so let's use it to create a quick recovery disk for the XL4. So using the shortcut on the desktop, I'll open that up, and here is the bootloader utility. I've plugged in a micro SD card into my computer which is showing up as drive D, and that is a 32GB SanDisk card. We want to make this a bootable micro SD for recovery purposes for the XL4. So all we have to do for that is select our controller, which is XL4 for the C-scan network. In my application, I don't require 4-channel high-speed counter mode, so I'll use the standard 2-channel high-speed counter mode, which is the default. Then, as I mentioned, my micro SD is plugged into drive letter D. And now I'll hit go. Now we could potentially get some errors when this is done. And you may wonder, why would we get errors if everything is working properly? Well, since we're creating a bootable micro SD in an operating system that is not Windows, then Windows is not going to recognize at least part of the drive that gets created. So in other words, there will be a partition that gets created that Windows does not recognize. So at some point after we've successfully gone through this process, we'll see an error message from Windows that says this drive is not recognized, or you need to format this drive, or some message like that. But ultimately, you are also going to see success messages from the utility telling you that everything worked fine. So let's leave this to complete, and let's see what happens. So here is my first Windows error message saying there's a drive that it can't access. That's okay, and that's simply a partition that it doesn't recognize. We also have a success message from our Bootloader utility that tells us that everything worked properly. So now we can eject the drive and use it on our OCS controller to recover from our failed firmware update. Going back to the OCS, let's use this bootable microSD card that we just created to recover this XL4. I've already installed the bootable microSD card, so now with my XL4 I have to flip dip switch number 3 away from its default position. There's currently no power being applied to this unit, so now I'll apply power with my bootable microSD card installed and dip switch 3 flipped over to its non-default position. So now that I've applied power, you'll see the XL4 is booting. I have some errors, but at least I'm booting now. And now I can complete the install bootloader process. Because remember, I want to get this firmware and bootloader onto the XL4 in its native memory and not just boot from the microSD every time. So this will take about a minute to do the update. There's a very important step here at the end that you don't want to forget. And that is, once we've completed this update process, we need to return dip switch 3 to its default position before we reboot again, because otherwise it's going to be expecting to boot from microSD. You can see we're complete here, so now I'll move dip switch number 3 back. We don't have to remove power to do that. So now I'll reboot the controller, and on boot we'll see some errors which are going to be related to two things. One, there's no program running on this controller, and two, because we didn't shut down in a controlled fashion, we may see a battery error. So let's see what errors we get here. So first we have both the types of errors we expect to see when we have no program, and we also have a battery error there. But if I do another power cycle, then that should get rid of that battery error. So now my controller is booting up, and let's see what errors we get once again. So I still see a no program to display error, but you won't see the flash of any kind of battery error. And if you do see that on the second power cycle, it means you truly do have a battery problem with your controller. Here I have no battery error, so everything is working and we've successfully recovered from our problem with the firmware update. Now we're ready to download our program from Cscape or whatever we plan to do. That's our demonstration complete. Thank you for joining me for today's tutorial, and the Q&A session will begin shortly.
Okay, nice run through of our bootloader tool. Not seeing any questions as yet. Okay. So we'll take you back. So next week we have screen organization, followed by the menu object and arrays, and then shift register instructions. That will take us a nice bit along. To find those firmware files, you can just go to support and firmware, and there's a tab then there. Okay, thank you all for joining us this morning. and we hope to see you again next week. Have a good day.